cities and not have as good access to a wide range of foods and a good diet, health went down, and actually people shrank by a fair margin. People got shorter and smaller. And this was an indication of poor nutrition. And then in the 20th century, especially after the second half of the 20th century, the health and access to a wide variety of foods in Europe and North America started to shoot our height up, and we're now actually have surpassed the pre-industrial height that we had been at a sort of an equilibrium for a long time. And we're actually now taller than we were 100 years ago, 200 years ago, 250 years ago. On average. Now, but when I say on average, I mean food is not necessarily distributed evenly around the world. I said Europe and North America has this secular trend of shooting up in terms of overall health and things like height, which is a good indicator of that. But you can see that actually certain countries, and there's some charts in your book, certain countries don't have as good of access to nutrition and actually are on a different trajectory than places like the United States. So as you're developing, you have nutritional requirements. But once you reach adulthood, the trick isn't to keep growing, it's to maintain what your body has produced. So it's that point that your genotype has become your phenotype, right? So when I was, 22, 23 years old, I pretty much was done growing. And my task at that point was to make sure that I maintained a healthy equilibrium. This is what's called homeostasis. That's your internal equilibrium. But as you get older and older, this becomes harder to maintain. So I once had blonde pigmentation. I no longer have blonde pigmentation in my hair. This is what we call senescence, where my body has a harder time maintaining the systems that my phenotype that was produced in adulthood. This is where biological aging starts to come in, and things like I get a white patch in my chin. This is your body's ability to do things like regulate bone mass. So this is where things like osteoporosis comes in, and both men and women are both susceptible, but unfortunately for women, it's a much bigger challenge to maintain bone density in older age, and the older you get, the harder it becomes. There's sort of a peak bone mass in about age 30 for both men and women, but men's bone mass is much more massive. And so that fall off means that it's not as much of an issue, but it is still an issue. And you don't want to, in your 80s or 90s, take a bad fall, because you will break bones, because your body has a hard time, even with nutrition, distributing them to create a healthy body. So here's a question. We've been talking about natural selection and adaptations. Why does menopause exist for human women? There are very few animals. We're not the only ones, but there are very few animals that have menopause. That is to say, menopause is when women stop having the ability to reproduce. They become post-reproductive. Now, we've been talking about biological evolution being all about passing your genes on to the next generation. That's really all evolution is surviving long enough to have offspring. So why would humans have a post-reproductive phase for females? not for males, because males can have offspring well into their old age, as old as you get, in fact. It may be a little bit harder in your older age, but it's possible to have children when you're over 100 as a man. But after the age of 50, it's very rare for females, women to have offspring. So why, and this is going to sound cruel, but why do women live after they're after they're no longer reproductively active, right? Why are they still alive? Why do women live longer than their reproductive age? And I'm asking this question because, biologically speaking, evolutionarily speaking, natural selection would select you to just have as many chances as possible. And forget about the idea that maybe they're not going to be healthy, or that it might be more dangerous for the mother, because nature doesn't care. Nature doesn't care whether you survive. You're not going to survive. I hate to break it to you. And it doesn't care whether your offspring survive. If you have, let's say, in your reproductive age, from, let's say, from puberty to age 50, how many offspring can you have? A lot, right? And many of those might survive. Many of those might be successful and actually pass their genes on to the next generation as well. But why not keep trying? Why not be a woman and have children until you're 80 or 90 years old? Why not? Okay, it kills you. Tough. You had children. You did your part. Just keep trying and just keep having offspring. Maybe those will be successful too. Maybe not. It doesn't make any difference, because you did have some successful ones. Okay, so it might kill you, as it might be more difficult or uncomfortable as you get older. Nature doesn't care about your comfort or how difficult it is for you. It does not care. Well, there's a hypothesis. We don't fully know why menopause exists, but go back for a moment to what I was talking about, the importance of the brain and socialization. Now, there's a hypothesis that's called the grandmother effect, that part of being a successful human is it's not only about being physically successful. It's about being socially successful, having a brain that can function in the way that it's adapted to, which is for social environments and understanding the natural world, making predictions about the future, having a little bit of creativity. These are important things for survival in humans. Now, who is socializing this? If there is a woman who is feeding a child that's an infant and trying to teach it things, trying to get ideas into that child's brain, you can't have another child, or it's hard to have another child and pay as much attention to that 1-year-old, 2-year-old that is starting to wean off of milk. If you want to have another child, it would help to have a little bit of assistance, especially assistance from someone who's been through the childbearing process. So, sort of in a weird, counterintuitive way, it makes sense biologically that there is a reproductive phase for human women, because you have more successful offspring by having a grandmother who helps to raise them socially, and that allows for the reproductive age, the younger woman, to have another child. So you end up having more children and more successful children because of that retired mother, right? So it's a concept, it's a hypothesis, and it's hard to test. So we might find some way to test this in the future. So I don't want to propose this to you as an absolute fact, but it's certainly, I think, an idea that has some legs to it. Right. So let's talk a little bit about, we've looked at development, but let's look at how some of our variety, how human variety arises. Because that's really where we started, talking about things like races and that sort of thing. Well, there's 4 levels of adaptation. So adaptations are an organism's ability to adapt to environmental factors, right? For success. There's genetic is one. We've looked at that in detail. We just looked at developmental adaptations. That's ontogenic or ontogenetic. There's acclimatization, which is physiological. We'll look at some of those things. And then there's cultural, which is behavioral. And we're going to look at cultural adaptations in later chapters. But the cultural adaptations are going to be an important factor in the essay that I'll ask you to do for this class. So functional adaptations are ones that occur during an individual's lifetime. And so that includes acclimatization and developmental factors, and they increase an individual organism's fitness for that environment. So do cultural, but genetics are things that you just simply either have them or you do not have them. You don't change them during your lifetime. Your genes are kind of fixed when you're born, or when you're conceived, I should say. So what do I mean by environmental stresses and environmental factors? Well, there's a lot, but there's some big ones that are pretty universal, right? So there is some temperature on the Earth, but not every place has the same temperature. If I were to go up to the Arctic or Antarctica, it's going to be colder than it is here in Las Vegas. So adaptations, and especially in extreme weather, are going to be things that actually are adaptations can result in differences in physiological features. So developmental so acclimatization and developmental adaptations can take place within an individual's lifetime. They can also be a factor in genetic. They can also be a factor in genetic adaptations, because those people that are able to adapt to those environments are going to pass their genes on as well. So being adaptable is something that you can acquire in your lifetime, but you can also pass the genes on for that adaptability. So heat stress is something that you can do, you do in fact. So vasodilation, if you're in a very hot environment, and we understand that here in Las Vegas, you're vasodilate. Now, basically, we talked about your circulatory system before, that your circulatory system is channeling nutrition around your body, getting it to the right places at the right times. But it also acts to move heat around in your body. And we're warm-blooded animals, meaning we have to maintain a constant temperature. If we get too hot, we'll start to have organ failure. And if we get too cold, we will start to get hypothermic. And your core area, your trunk, your chest, is the most important part. You can lose an arm, you can lose a leg, but you can't lose a heart. You can't lose your lungs. So your body actually has instructions in your genes to prioritize these things. And so those successful individuals or organisms, we actually are able to adapt to heat on the fly, on the go. And so your body knows that if it's very hot, it's going to, your circulatory system is going to expand, dilate. So vasodilation means you're going to be moving more blood around in your body, and that brings the heat to the surface where it then radiates out of your body and keeps you cool. We also don't have as much hair as other primates. Because that actually keeps us cool. And also, we have cultural adaptations that mean that if we do go into cold environments, we can put clothes on. So we can go into very cold environments, but it indicates that our hairlessness indicates that we're actually adapted to hot environments. That will become an important factor later. So humans come from hot climates, the first humans. We also sweat. Now, I don't know if, I guess a lot of people here in this city have what are called swamp coolers, or on your car you've got a radiator. Basically, the concept of a swamp cooler, or something like, I don't know if you've ever seen these sort of traditional military style canteens. They've got it's a flask, you put cold water in it, and then there's a sleeve that goes around it, and it's got padding that you're supposed to dip in water. And if you can leave this canteen with the canvas and padded sleeve around it in the direct sunlight, and you'll still have cold water inside, because the exterior wet canvas sleeve will start to evaporate that water first. That evaporation will absorb the brunt of the sun's energy, and as long as that's wet, it will evaporate before it heats up what's on the inside. That's the same concept for sweating. Is that you're creating a layer of water that is then evaporating, and that means that the sun, even if it's directly on you, is not heating you up too much, because the evaporation is taking place first. All that being said, there are some rules about your body type, that a short, stocky, thick-trunked human is not going to do very well in hot environments. And the reason for this is because you need to expel that heat out of your body. That if you're just constantly absorbing heat, you can overheat in that environment. So a body that is long and thin with long limbs and a small, narrow trunk is something that's going to have more surface area to body size, and you're going to radiate heat better than so a long, thin body type is going to be more adapted to heat than to cold weather, and vice versa. This is what's called the Bergmann's rule and the Allen's rule about your body types, and you can read in the book a little bit more about that. And the opposite of some of these things are the case for cold stresses. So you're in cold weather, your circulatory system constricts. Because what it's trying to do is keep all that heat inside. Now that is where hypothermia comes in, is you're not having as much blood flowing to your extremities, because it's trying to keep it all in the core. It's trying to keep you alive. And so you vasoconstrict. You also shiver. You can shiver and chatter your teeth. That's actually your body making kinetic energy that's literally warming you up just from vibrating. You also, in cold weather, people can have elevated basal metabolic rates that keep the rate at which your fuel or your consumed calories is metabolized within your body. And so higher basal metabolic rates tend to be in colder environments. And once again, body types in cold weather tend to be larger, wider bodies with shorter limbs with less surface area that the cold can affect. And of course, we have cultural adaptations too: clothing, houses, shelter, artificial heat sources and that sort of thing as well, which allows us to live in very cold environments. Now, another adaptation, another environmental factor that's pretty universal is the sun, right? So it's not just the temperature, but the amount of sunlight that exists in that area, especially UV radiation. Ultraviolet radiation varies on the Earth because we're on a sphere, spheroid, the Earth, and we go around the sun, and we're on an axis. So the sun's light is reaching us at this at an angle, and the equator is where the sun hits the most directly, and there's the most UV radiation at equatorial regions. But at the poles, you're getting that sun deflected and refracted through the atmosphere, and you're not getting as intense of UV radiations. And so why is that important? Well, we need ultraviolet radiation to live. One of the most important reasons why is because our bodies do not metabolize vitamin D on our own. We require sunlight to do that, and sunlight that's absorbed through our skin. So you need sunlight, you need ultraviolet radiation, but too much of it can be harmful because, as we talked about before, radiation can cause mutations and it can cause cell damage. So what you want is exactly the right amount of UV radiation to have a healthy system and have enough vitamin D that your body can use. But UV radiation varies from place to place. So your latitude, where you come from in terms of latitude, is going to affect your amount of UV radiation that you get. And a couple of scientists, Jablonski and Chaplin, came up with a hypothesis and tested it, and we now understand this to be the case, that darker skin has low skin reflectance and is associated with higher levels of UV radiation, whereas lighter skin, which has high skin reflectance, is associated with lower levels of UV radiation. And essentially, what you can do is you can take a map of the planet Earth and see where UV radiation is most concentrated, and we're talking the equators, and it falls off, maybe not at an exactly uniform rate, but the further you go towards the poles, the less UV radiation you're getting. And you overlay that map onto the average skin tone of indigenous populations around the Earth, and you will see that the darkest skin color is where you have the highest levels of UV radiation, and there is